Hello students, today we will be solving the IB Math EAHL May 2024 paper 1 time zone 1 question number 11. You will be getting the other solved past paper questions of this paper and of the other papers in form of playlist on my channel NS Online Math Tutoring classes. You will also be getting playlists where the solved past paper questions will be grouped by their topics. I am Nilanjana Sanyal. I am an online IB Math EAHL level tutor. In case you want to join my classes, please contact me for more details. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start answering question number 11. The maximum mark is 17. It says consider the polynomial p of x equal to 3x cubed plus 5x squared plus x minus 1. So part A's question is show that x plus 1 is a factor of p of x. It is containing 2 marks. Okay. So the factor theorem says that if p of negative 1 is equal to 0, then x plus 1 will be a factor. So we will be showing that p of negative 1 is equal to 0. You can also divide this polynomial p of x by x plus 1 using either the synthetic division or the long division, and you can show that the remainder is equal to 0. But I am not doing the division. I am just getting the value of p of negative 1. Okay. So p of negative 1, this is the part A's answer, is equal to 3 times negative 1 to the power of 3 plus 5 times negative 1 to the power of 2 plus negative 1 minus 1. So this is equal to 3 times negative 1 whole cube is negative 1 plus 5 times 1, and this one is minus 1 and this one is also minus 1. So 3 times negative 1 is negative 3 plus 5 minus 1 and minus 1, which is equal to 0. Okay. So p of negative 1 is equal to 0. Therefore, using the factor theorem, we can see that x plus 1 is a factor of p of x. Okay. So part B. Hence, express p of x as a product of 3 linear factors. Okay, for this, let us avoid doing the division. I am writing this 3x cubed plus 5x squared plus x minus 1. This is equal to, or let me write this is equal to over here, x plus 1, because x plus 1 is a factor of this, and the other factor will be a quadratic factor because this is a cubic polynomial. Okay. So, and quadratic factor, the highest power of x will be 2, and the coefficient of the term containing x square will be equal to 3 because this is 3x cubed and this is x. So I have to multiply this x with 3x square. Only then can I get this term 3x cubed. So I am writing this as 3x square plus, I do not know what is the b. So I am writing bx. And what about the constant term? I am seeing the constant term is negative 1. So this is the constant term from this factor, which when multiplied with this constant term should be giving the product as negative 1. So I can write this one as negative 1. Okay. So this is the quadratic factor and I have to get the value of b. And after I get the value of b, of course, I can factorize this quadratic expression and I can get 3 linear factors. Okay. So how can we get the value of b? Let us try the x squared. Okay. So how can we get x squared? X square can be obtained when 1 is multiplied with 3x squared. So I'm just expanding the right hand side. For x squared term. Okay. So 1 times 3x squared is 3x squared, and x times bx is bx squared. These are the only two ways of getting a term containing x squared. So 3x squared plus bx squared should be equal to 5x squared from LHS. Okay. So bx squared equal to 5x squared minus 3x squared, which is equal to 2x squared, which gives us the b value as 2. Okay. So I can write the quadratic expression as 3x squared plus 2x minus 1. So now I can factorize this part. It will be 3x squared plus 3x minus x minus 1 equal to 3x x plus 1 and minus 1 x plus 1. So this is equal to x plus 1 and 3x minus 1. Okay. Therefore, p of x is equal to, this is there, and that was x plus 1, and this is also x plus 1. So I can write this as x plus 1 whole square, but they have asked us to give this in the form of product of three linear factors. So I'm writing this as x plus 1, and 3x minus 1. Okay. So this is the answer for the subpart B. Now consider the polynomial q of x equal to x plus 1 times 2x plus 1. Subpart C's question is express 1 over q of x in the form of e over x plus 1 plus b over 2x plus 1, where e and b are integers. So we have to express this as the sum of the partial fractions. Okay, so let me come over here. 1 over q of x is, okay, let me write 1 over q of x. This is equal to 1 over x plus 1 and 2x plus 1. Okay, so this should be equal to, given this should be equal to x plus 1, a over x plus 1 plus b over 2x plus 1. Okay, and then I am multiplying the entire equation. Entire equation means this part. So I am multiplying the entire equation by x plus 1 times 2x plus 1. Okay. So if I multiply the entire equation by x plus 1 times 2x plus 1, the numerator will be 1 and these will be getting cancelled. So the left hand side will be equal to 1. And then if I multiply this first term with x plus 1 times 2x plus 1, then the x plus 1 part will be getting cancelled. So this will be a times 2x plus 1. Similarly, plus b times x plus 1. Okay. And now let us take different values of x. I'll be taking that value of x which will be making one of these two factors equal to 0. So first of all, let me take x equal to negative 1. The left hand side is 1 and this is e times 2 to the power of negative, means 2 times negative 1 is negative 2 plus 1 is negative 1. So negative e is equal to 1, therefore e is equal to negative 1. Okay. And then when x is equal to, for making this part equal to 0, I have to take x equal to negative half. 2x plus 1 equal to 0 means x equal to negative half. So I'm taking the x value as negative half. So now 1 is equal to a times 0 is 0 and b, this is negative half plus 1. 1 minus half is half. So this is half b. Okay. So therefore b is equal to 2. 1 equal to half b, so the b value is equal to 2. Therefore, 1 over q of x is equal to, a was equal to negative 1, so it is negative 1 over x plus 1 plus b is 2 over 2x plus 1. Okay. Fine. So now coming to subpart D. Hence or otherwise show that 1 over x plus 1 times this. Okay, let us see. It is containing just 2 marks. Let's see. So 1 over x plus 1 and q of x was x plus 1 and 2x plus 1. Okay. So this can be written as 1 over x plus 1 times 1 over x plus 1 times 2x plus 1. Okay. And for this part, we know this is equal to this. So let's see. So this is equal to 1 over x plus 1. And this is negative 1 over x plus 1. And then it is plus 2 over 2x plus 1. Okay. So this is equal to negative 1 over x plus 1 whole square plus 2 over x plus 1 times 2x plus 1. Okay, so this is equal to, this one stays. You see, minus 1 over x plus 1 whole square. This one is staying. But I have to change this. I have to express this part as partial fractions again. Okay, so this is equal to, let me write the first term as it is, plus 2. And this is 1 over x plus 1 times 2x plus 1. And which is q of x. Okay, so we know the expansion of this. This will be again equal to that part. Okay, the two terms. So this will be equal to negative 1 over x plus 1 whole square. And then 2 times I'm taking this one first term. So it will be negative 2 over x plus 1. See, negative 2 over x plus 1. And then finally plus 4 over 2x plus 1. So rewriting this, we get, therefore, 1 over x plus 1 times q of x is equal to, which one did they write first? Okay, 4 over 2x plus 1 minus 2 over x plus 1 and minus 1 over x plus 1 whole square. You can do it this way, or else you can start with this and you can just separate. This will be x plus 1 whole square. So let me write it over here. This will be 1 over x plus 1 whole square, and this will be 2x plus 1, and this should be equal to a over x plus 1 plus b over x plus 1 whole square plus c over 2x plus 1, and you get the values of a, b, c separately. You can do it this way because they have set hence or otherwise. You can start from the very beginning and get the values of a, b, and c separately, or you can use the previous subpart to get the answer of this subpart. Okay, and this is shown. Okay, now hence, this is just hence and it has to be hence. We have to integrate this. So this is nothing but 1 over x plus 1 times q of x, which is this one. Okay, you have to realize this, that it is nothing but 1 over x plus 1 times q of x. Okay, so it is subpart E. One over x plus 1 whole square 2x plus 1 dx is equal to, I'll be taking these three terms, 4 over 2x plus 1 minus 2 over x plus 1 minus 1 over x plus 1 whole square dx. Okay, let me separate the terms. So it is, I'm taking the 4 outside, 1 over 2x plus 1 dx minus 2, 1 over x plus 1 dx and minus 1 over x plus 1 whole square dx. Okay. So now, if you can do the integration directly, it is very good, or else we have to use the substitution method. We do not have any other method that we can use. We have to go for the substitution. Okay. For the first integral, I'll be substituting 2x plus 1. So it is, let t be equal to 2x plus 1. So dt by dx will be equal to 2, or dx will be equal to dt over 2. Okay, so this is the rough portion, and so this is equal to 4, and it is 1 over t, and dx equal to dt over 2. So I can take this 2 outside, 1 over 2 and dt. What about x plus 1? If I substitute t equal to x plus 1, I'll be getting dt over dx as 1. So dt will be equal to dx. Okay. So it is minus 2, 1 over t and dt. What about x plus 1 whole square? Again, I'll be substituting x plus 1. It is not that I'll be substituting x plus 1 whole square. It is just x plus 1. Okay. So if I substitute x plus 1, it will be dt equal to dx. So now I am getting t to the power of negative 2. This will be 1 over t square. So I am writing this as t to the power of negative 2 and dt, which is equal to 2 ln of t. That one is minus, okay, let me not take t. If you get confused, this t, do not forget, this t is 2x plus 1 and these two t's are x plus 1. Do not forget. If you get confused, then you have to take some other variable. You can take, say, you can take k, you can take u, you can take any other variable, but not t. But in case you take all of them to be equal to t, you have to remember that this t is representing 2x plus 1 and these two are representing x plus 1. So this one is, next one is minus ln of t, and this is minus t to the power of negative 2 plus 1 over negative 2 plus 1, and of course there will be the plus c. Okay, so this is equal to 2 ln of 2x plus 1 minus 2 ln of x plus 1, and this is minus 2 plus 1 is minus 1, and this is minus 1, so this will be plus. And t to the power of minus 2 plus 1 is t to the power of negative 1, which is 1 over t. So plus 1 over x plus 1 plus c. Okay, this is the answer for the subpart E. Okay, coming to subpart F, I hope I'll be getting sufficient space for solving this subpart F. Find, these are two for the subpart. Subpart I is limit of f of x. First of all, consider the function defined by f of x equal to p of x divided by x plus 1 times q of x, where x is not equal to negative 1 and x is not equal to negative half. Okay, and now the question, subpart F's question. 2 for the subparts, find the values of these two limits. Limit x tends to negative 1 f of x. This is the I's question. Okay, so first of all, let me write the expression for f of x. Okay, so this is the question for the subpart I of subpart F. F of x equal to p of x over x plus 1 times q of x, and p of x was equal to 3x cube plus 5x squared plus x minus 1, and q of x was equal to x plus 1 times 2x plus 1. Okay, and okay, let me first of all write this. It was 3x cube plus 5x squared plus x minus 1 over, this is x plus 1, this is x plus 1, so I'm writing x plus 1 whole square times 2x plus 1. And let us see, we had factorized this. So let us get the factorized form of the numerator. P of x was equal to x plus 1 whole square times 3x minus 1. Okay, so this was x plus 1 whole square times 3x minus 1 over x plus 1 whole square times 2x plus 1. So these two can get cancelled, and this will be equal to 3 times negative 1 minus 1 over 2 times negative 1 plus 1. So this is minus 3 minus 1 is minus 4, and this is 2 to the power 2 times negative 1 is negative 2 plus 1 is negative 1. So this is equal to 4. So this is the answer for the first subpart of subpart F. The second subpart's question is limit x tends to infinity f of x. Okay. Limit x tends to infinity f of x is equal to limit x tends to infinity, and I'm keeping this as it is because whenever it is, the limit is x tends to infinity or something is tending to infinity, we will be trying to get its reciprocal, because its reciprocal will be tending to 0. If x tends to infinity, then 1 over x should be tending to 0. So we will be trying to get the expression in terms of 1 over x. Okay. So therefore, I am not getting the factorized form of the numerator for this case. Rather, I will be expanding this. So 3x cubed plus 5x squared plus x minus 1 over, this one is x squared plus 2x plus 1 and 2x plus 1. This is equal to limit x tends to infinity 3x squared plus 3x cubed plus 5x squared plus x minus 1 over 2x cubed. Okay. And then this is x squared times 1 is x squared, and this is 2x times 2x is 4x squared. Okay, so x squared plus 4x squared is 5x squared. 5x squared, and then this is 2x. 2x times 1 is 2x, and this is 1 times 2x is another 2x. So 2x plus 2x is 4x. And then the constant term is plus 1. Okay. And I am dividing both the numerator and the denominator by the highest power of x. That is x cubed. Okay. So, because I want to get the expression in terms of 1 over x or 1 over x squared, because those will be tending towards 0 as x tends towards infinity. Okay. So, I'm dividing both the numerator and the denominator by x cubed. So, therefore, 3x cubed divided by x cubed is 3 plus 5x squared divided by x cubed is 5 over x plus x over x cubed is 1 over x squared and minus 1 over x cubed. Divided by 2 plus 5 over x plus 4 over x squared plus 1 over x cubed. Okay. And this can be written as limit 1 over x tends to 0. So 3 plus 5 over x, which will be equal to 0, plus 1 over x squared. 1 over x tends to 0, so 1 over x squared will also be tending towards 0. Next term will also be tending towards 0. Similarly, the terms from the denominator plus 4 over x squared plus 1 over x cubed is equal to 3 over 2. You can write 3 over 2 or you can write 1.5, whatever you want, you can give the answer. So this is the final answer for the second subpart of the subpart F. So this is all for this question. We have completed answering this question number 11. Thank you for staying with me till the end. Please like this video in case you have liked my explanation, and please share this video with your friends so that even they can get benefited by watching my video. And in case you have not subscribed to my channel, please subscribe to my channel. It will be motivating me, helping me, as well as your likes, shares, and subscribe will be telling the YouTube that my videos are worth watching, so the YouTube will be showing my videos to more number of students. That will be helping me a lot. We meet again very soon in our next session. We'll be solving the last question of this paper. So till then, bye.